Welcome back, episode 109, and today we're going to be talking about engineering. Given we are two mere mortals, but we're also two engineers. We're going to be talking about what do you actually do as an engineer, and we're going to have two different stories about it. Our own personal stories around that, and what are the worst moments of being an engineer, at least, and then we'll get into a few other things.
Nice.
Now, Karen, how are you, sir? You're wearing a very nice suit. I like
Thank you, sir.
the outfit, the tie, the shirt.
I'm feeling good.
When was the last time you wore something like this?
Let's see. I went to a wedding in January at least, so and I think probably something in between then and now.
Okay.
I think maybe.
Yep.
Don't quote me on that though.
All right.
So
I think for myself,
yeah.
I haven't worn this suit jacket maybe in about 2 years.
Yeah. Okay.
2 years or so.
It's so funny because I thought you'd be wearing suits and stuff all the time.
I thought so too.
With your work. And
We'll get into the engineering. Actually, that's another one. We'll get started with the outfit of an engineer. So we'll get into that.
Before we really dive into it, so I just wanted to mention this right here, right now.
Yep.
The interviews, they're changing. We're changing the name. A little bit of a change up to Mere Mortal Conversations. Realized we're doing more of a conversational style. So if you're looking at that, you'll see the numbers are resetting down to number 1. So number 1 is coming out this Saturday, and they will be Mere Mortal Conversations from now on. Still with the same thing. Black, or the black dark gray background is more the serious structured ones.
Yep.
The white with the darker writing is the more free flowing. Like we're just.
And why did you think resetting it? Why the reset to back to 1?
Well, to be honest, I didn't really think that much of it. I was just like, well, if we're going to call it Conversations, we'll start it again. Okay. That was my reason.
Okay. That's it. That's how it rolls. That's how it rolls.
Yeah.
Mere mortal moment, of course. Let's begin with that.
Let's do it. All right. So mine is, just because you are something now doesn't mean it will last. Prepare for the day it won't describe you anymore. Boom. Engineering. Kyron used to be an engineer.
Yep.
I would not feel comfortable calling myself that anymore.
No.
I very much doubt Juan would as well. But it does make up part of your history. And, I never really dived into that identity of Kyron the engineer. It was just something I did. It was more work, so it was a bit more separated.
Yep.
But, I've had that, I think I've mentioned before with soccer. I used to be Kyron, the soccer player.
Yep.
With Kyron, the pickup guy who would go out and try to pick up chicks, that sort of thing. So
your identity morphed over time.
And it always will. So I think it's okay to latch onto it and describe yourself with it, but also don't do it too much. Otherwise you get stuck in things. Yeah,
it can be detrimental. Mine is scientists dream, engineers do.
Ooh.
Scientists dream.
Shots fired.
Do. Yes. You all may dream, but engineers do. And the reason I thought about this was we do a lot of doing. I particularly am aggressive in my doing. So, and I was trying to think a little bit about it from an engineering perspective. You find a lot of that from an engineering side of things, and either from what you train, what you learn, but it's a little bit more practical. It's a little bit more pragmatic than the scientific way. There's a little bit of hypothesis in there, but we'll get into some stories of actually working as an engineer, and there's a bit more. You just got to make things work. You're at that boundary point. You're not actually doing the work. You're not in the front line, but you're getting a little bit closer to it.
Yeah.
So there's a difference between the people who creates the steel, designs the steel, designs the engineering for the steel, and then the people who actually put together that steel for the house, whatever it may be.
So letter E today, engineering. I also picked this topic just because I thought it's a little bit of a showing of us. We don't really talk about it that much, but it took up 4 years of our lives plus however long you worked. I think it was a year or 2 years.
Yeah, well, so that plus me doing masters as well. So it was a big period of time doing engineering.
So like 1/5 of our lives, I guess, roughly for both of us caught up in this.
Yep. So, the suit jacket came from engineering.
There you go.
Now,
surprised it still fits. To me.
Define it. Definition. Give me this. Have you got any definition for me of engineering?
The application of mathematics and physical sciences to the development of technology and design of engines, machines, structures.
Oh, I like it. I wouldn't have said it any different to that. I like that. And and it is broad. I had a bit of a note on how many different types of engineering there is. Yeah. And I couldn't really find a specific figure of this, but
see, I did the same, and I found something like the 6 core or the 4 core engineering disciplines.
Which would be electrical, civil. I didn't even know there was. Really? Yeah, I'm assuming it'd be electrical, civil, mechanical, and maybe environmental. I think is the other one. Or something else?
I don't think environmental was like.
I think at QT that was like the 4 core things.
Yeah. I mean,
but QT didn't really have mining. So
could have been structural, could have been processing.
Well, structural is under civil.
Maybe processing, but that's sort of under chemical as well.
Jeez. And here's the thing. So here's a couple to give people an idea, right? So first and foremost, I was a civil with a major in structural engineering.
Yep.
Karen?
I think it was. The degree was actually called Bachelor of Engineering, majoring in mining.
Okay.
I think that's what it said.
There you go. So there's other things, right? There's aerospace, biomedical, chemical, there's civil, computer, electrical, environmental, forensic, genetic, mechanical, military, nuclear, reverse, software, structural. Man, there's so many. You could almost pick anything and put engineer next to it, and it's probably exists out there somewhere.
Yeah, I just saw there was like a list of 40, and it just went, okay.
Yeah. So let's begin with something. So we were talking about it. Outfits.
Yep.
So suit jacket. I'm going to talk about the suit jacket. So I'm going to take you back. I bought this in 2015, 16, I believe, somewhere around there. No, maybe even earlier. 2015, maybe around there. Yeah. And that's when I was sort of working as an engineer at that point at Brisbane City Council. So at a council. And I was moving into this transition period of going from a local government to a private engineering firm. And at that point, I thought, okay, this is where it's going to get hectic. It's going to get fancy. So I went to, drop him here, Suit Society. Go check those guys out as well.
Mm-hmm.
Jonathan, awesome guy. I went to Suit Society, and you walk in, you're talking about, I want to get this nice custom fitted suit with the right shoulders, and I get bigger and I get smaller, so I need to be tailored for all this. Cool, excellent. We've got you covered. But then they ask you, well, what's your profession? And then mine was engineering. Now, if you're an engineer, the choice is, say, you got to go the black, the grey, the dark grey, the black. That's an engineer's outfit. And I was like, fantastic. Now, I bought this, and I reckon I wore it in those 2 jobs that I worked at, that local government, and then following from that at the private firm. I probably wore it a total of 3 times, if that.
Yeah.
And it's because my work was much more aligned to working with frontline workers, construction workers, everything else in the structural area. You basically, if you're an engineer, I reckon these days, you'd be hard pressed to see yourself in a suit. That's still, the suit still exists for a lot of other professions.
Yeah.
But for engineers, my mindset of thinking, it'd be kind of like that banker look. No, that is not what it is to me.
Well, I was watching too much Suits before.
Yeah. Well, I think I watched Suits much later than what other people were watching it. Look, my outfits in engineering and all the time that I was in engineering ended up being, like if I was working in a normal office, a normal button-up shirt, not even a tie.
Yeah.
And, it started going more easygoing the more and more I was in engineering. I remember seeing a couple of the partners at one of those private firms rocking up with shorts and like Hawaiian shirts at a Wednesday or a Thursday, just chilling out. So it can get pretty crazy. What about you?
Nice. Well, yeah. So I did mining, which is basically requires you to go out to the mines unless you can find work in the cities. There are, BHP, Rio Tinto has I believe it has its headquarters in Brisbane. Don't quote me on that though. It definitely used to.
Rio.
Yeah. And so you can work in there. I never did though. I went straight from my engineering degree, did like vacation work out in the mines. So that was where I started to acquire some shirts and some long pants, high vis.
Yep.
Then I went straight up to Mackay and worked at Hale Creek Mine. So I got just standard sort of orange and blue with a couple of like reflective strips on it.
Yep.
Dark blue sort of jeansy type pants. Steel cap boots, of course, and the hard helmet.
Steel cap boots. So another little story. I bought my first and only ever pair of steel cap boots for that private place I worked at because I was going to go to site a couple of times.
Yeah.
Now, between the time that I bought those steel cap boots and the time I left the company, wouldn't have been more than 10 days, 8 days, just because of I was moving on and I forgot them. I left them under the desk before even ever using them. So I bought them, took them to the office, worked for a couple of days. Then we were finishing up, never took them away. I even sent them messages asking, can I please get my steel boots, blah, blah, blah. Never heard back from them. Never was able to collect those steel boots again. Man. So they're not cheap. They were not cheap. And as young adults at that point, That was an investment in my bloody career. So,
well, here's my first steel caps. So I had to do a practical in one of the labs in the university.
Yep.
And you needed to have steel caps for it. Now,
don't tell me you got volleys.
My parents were teachers, and so I was like, well, what am I going to get? And I was way too self-conscious. I didn't want to wear them in. I didn't want to have a big bag. They were too bulky to carry in as well. I mean, they weren't, but it's just me being me. And so you can actually get steel cap Dunlop volleys.
Yeah.
And
so to people, because I know we got a couple of listeners from Spain, US, other areas, a Dunlop volley with steel cap boots is essentially get you like a running Nike shoe that's a little bit reserved and just put a steel cap on that. That's basically what it is. So
it was so lopsided, man. It was so heavy at the front, obviously.
That's cool. I like it. Now, I reckon, we got a couple of listeners I know that are quite young, some other individuals who are parents. What got us into engineering? Why we got into engineering, and would we recommend it now? So we can follow up with that. But first for you, what got you into engineering?
I'm just trying to think like what's the best way. I'll start with the early signs because that helps a little bit, and I want to see if these match with you as well. So early signs, I think that potentially might indicate someone's an engineer. Naturally good at maths. An interest in those sort of mega structure things. So I don't know if you ever had Foxtel and it was, mega dams, mega factories, mega ships.
100%.
All of those things. I used to watch them and really enjoy them. So annoyance at shit not adding up. So if I had, whatever, it could be related to finance, it could be a math problem, it could be anything. If it didn't fit or even like a ruler or something, or I was measuring something and it was meant to fit this gap.
Yeah.
Playing with
has
the
to
toy
be precise.
And, the toy, you had to assemble these pieces and it didn't fit. That would annoy me.
Yep.
Probably playing with Lego and Kinects and that sort of shit.
Yep.
What else? I love Questacon. So if you're in Questacon, a lot of people, I don't know why, you must have missed out on this, but a lot of people would go to Canberra for their grade 6 and grade 7 trips. And then at least in my area, I don't know, it seemed like lots of schools did this. And you would go to Questacon, which is the sort of like Canberra Science Museum.
Dang. I have heard this.
Real interactive things where it's like, we'll teach you about friction we'll have like a giant sort of skate ramp thing and you put on this frictionless suit and then you hang above it and it's like you're hanging a couple of meters above this giant ramp and then you let go and then, because it's just angled, you just float down.
Gotcha.
Stuff like that. I really love going there.
Yep. And there's an equally one in Brisbane in South Bank in the downstairs area of the museum where they've got like a science center and you can do that sort of stuff.
Yep, that sort of thing. Just big things, man. Like big buildings, whatever it was. I love that. And then the most important thing that made me an engineer, I had no idea what else to do.
Yes.
So, my dad sort of suggested it. I guess it was always the plan to just go to uni to do something at uni. That was naturally smart. I was just good at school. So I sort of followed on, I'll do that. And then he suggested, okay, why don't you do engineering?
Okay.
Yeah. I'll do that. Now, why I specialize in mining, that one actually has a bit more direct. So because I was going to do engineering, Dad's like, all right, I have some friends who work in engineering workplaces. I'll see if I can get you to go there for a day on a weekend or a week or whatever.
Yep.
So I went to my uncle's electrical engineering type workplace. Another friend, I think another one, which I can't actually remember, which obviously shows how much I cared. And then a mining one. And in the mining one, I got to meet a recent graduate who was, I guess like 22. And I just thought he was, super old, as you do when you're
whatever, 16,
old.
17.
And he was working on a big open scale pit using Vulkan, I think, which is one of the mining softwares, which is essentially like a 3D model. So it shows you, everything in, you can zoom in and make it transparent and all these sort of cool things. And I saw that. And then he also showed me a slideshow of a dozer that got trapped in one of these big machines. And it was like a big, it was a big stuff up. It was basically a huge like claw type machine. And the dozer accidentally got in front of it and it got flipped up and chucked onto it. I was like, whoa, that's cool.
So like, this is for me. This is mining.
Yeah, so that's I had that, good,
cool,
fond memory of mining. So when I chose UQ because they had mining engineering, and then that's sort of how I got into it. And then once I started it, I was going to finish it. I don't think there was any doubt about that.
Unlike Stephen, we'll get to that. Now, mine's a little bit different, and maybe use a view from a foreigner view. So I'll give you this insight. So the foreigner, I guess, to Australia, but at that point I've been living here for 8 years. 8 years. Now at that point, my mindset was really, okay, all the things we talked about, like maths, physics, all those sort of things. And I was thinking, okay, if I'm going to go to university, it's going to be the good stuff, law, medicine, engineering, those sort of things. Yeah. Now, not to say that that's the top things, but it's just what in my mind as a 15, 16-year-old, I thought, I've got to go and do this. But my path was a little bit different because at the onset, I was going in for chemical engineering. So it all began in year 9 and year 10. I loved chemistry. Now, I had a teacher that loved me. I could do anything in this class. Yeah. Like, I'm talking setting books on fire. Loved me. It didn't matter.
I'm talking Juan playing, what's that machine where you have to hit the gopher that pops out of the hole? Whack-a-mole.
Juan
was doing that in class. She would turn her back. Juan would go and there was only 7 of us in class. One would scurry under the seats, go to the other side, pop up, and she'd look, see one over there, then she'd look back, and then he'd be over here.
He was a
menace.
It was a menace, but loved it. Loved chemistry. Now, in year 12, I took university chemistry. So I took university chemistry thinking I was going to go, okay, this is going to be, I want to go do chemical engineering. And that led me, I was going to go to UQ because at that point, the University of Queensland was the only place I was doing chemical engineering in the area. So that was my initial thinking. But something transitioned in me between year 11 and year 12.
Girls.
I loved year 11 chemistry. By the time year 12 came along, I was so bored of it.
Oh, really?
Oh, it was just valence and everything else. And I was like, I just don't care anymore. Yep. I think it intrigued me, the very first portions, but that following almost like biochemistry sort of discussions and full chemistry, I just thought, nah. Not for me. Now, at the same time, I was also doing aerospace engineering. You call it aerospace in school. And that's what got me direct entry into university. So I didn't actually have to rely on an OP back in the day or the ATAR for the kids of today and everything else. I just went in with my aerospace accolades and be able to go into university. And I even have a couple of newsletters from QT and on the Logan newspaper saying, Juan Granados going in for aerospace engineering, and these are all the things he wants to do. What do? So first year in university at QUT, and at that point you get to trial, obviously, in the first years. You get to trial a little bit of electrical, water, civil, environmental. And at that point, my love of, I guess, big buildings and everything else took over, and I thought, nah, civil engineering's for me. That's what I'm doing. And then it went from there.
Nice.
So, and again, once you started, I've never had the idea that I was ever going to drop out. There was never that idea.
Yeah, I met a dude in my very first month there who was starting with me, and he was a bit older. He was probably 27.
Yep.
Once again, getting even older. And I was just talking with him, and he's like, yeah, you know what? I did dentistry for 3.5 years. It was a 4-year degree. I dropped out because I realized I didn't enjoy it. Just went, man, just finish it at that point. Just get it over and done.
I knew some folks who did engineering, then started the PhD in engineering, stopped, then went to dentistry.
Oh.
They're still doing it to this day. They're still doing it to this day. That is nuts.
There's crazy people out there. I just wanted to touch on it. You touched on it a little bit. So going into engineering, what's it like? I think it's just fun to at least describe the first year. For the first year for me, as you mentioned, it's like a trial sort of thing. So you'll do a lot of math-based courses, a lot of, I guess, like material-based ones.
Gee, I can still remember MAB 125, MAB 126.
Mate 1000 for me.
Dang.
Math 1051, 1052. And there was like just a general engineering course where you can sort of pick like little topics, a speciality for a semester, and you try that out. And I did that, and I suppose one of the things is just going into these huge lecture rooms. 600 people crammed into this one room. How many guys do you reckon it was? Probably, do you know what starting it is?
Or something like
probably
that.
80% starting up. And it's just dominated like that. It's just very male.
Although I don't know what it'd be like today, to be honest with you.
Yeah, it could be. I mean, there definitely is more of a push for females in that. I got a random job offer, or not job offer, an advertisement for a job through my email. And yeah, once again, it was just, it's the same thing though. Like, particularly if you're a woman or a Torres Strait Islander, apply. We love having that. And so it's like, okay, if you do that, so that obviously there's still a shortage of female engineers. And yeah, that's just what it was like. Just masses of people. It was just very, very popular. And then it would dwindle down. You'd choose your speciality for the second year. And then it would, I guess, be a fifth, a tenth of those massive classes. And then each year after that, you'd probably lose, I don't know, 10%.
Whatever, maybe. Yeah, well, an example. So for me, I think the very first class, we all sat down. They couldn't fit everyone into this massive amphitheater, but it was around 1,080 people signed in for the first year of engineering, the year I did QT. So that's in 2010. That's when I went into university, QT. And by the time I graduated in 2013, there was a class for advanced structural engineering, which had 20 people. 20 people. Now, people went into the different areas of water engineering and electrical,
and people fail things, so they have to redo.
It dwindles down quite hard.
Yeah.
One thing I was going to touch, so again, first year engineering, what can you expect? So if you're listening to this and you're young and you're thinking, what am I going to expect? And again, there's a little bit dated now. This is, 7 years more.
2010. 2010.
So this is 10 years. This is 10 years delayed. So who knows? But it probably still premise exists. There's two clear paths. I really didn't see it as any different, really. And you tell me otherwise. I think a majority of portion, it's party time. Now, if you go to university, college, whatever it may be, that first year, you've got so many people, you've got all these things that you learn, but the courses is easy. Let's talk about it. If you're going into engineering, in any practice, you're probably well informed, and what they try to do in the first year is baseline everyone. Get everyone up to scratch on what's the mathematics you should know, what's a talking, how to work with people, how to work in groups, how to deliver based on your own learning. They're not teaching you really detailed analytical things or practical things in the world. You're learning how to work with others, how to set the basic problem solving techniques.
Yeah, I wouldn't say easy. I'd say passable.
Possible.
I think
easy might be the wrong term.
Still getting good grades, getting those 7s in the first year. I think difficult. It's still difficult.
But it's difficult in the sense that you're probably going to not get 7s or 6s or the high grades because of the way that you interact with other humans and teams and how you know how to set exams and be disciplined with your own work. If you're already that, it's probably pretty straightforward to do that in your first year. Later years, that changed completely. But then I saw this clear thing. Around 80% of the people I saw, party goers. So it is every fortnight, there's an engineering drinks event, there's boat parties, there's everything else. Who knows how that's going to be affected based on coronavirus. But it's the college university life of getting to know other people and whatever else. Now, that particular time in my life, I had a partner who was at a different university. I met a good friend of mine, Jimmy Kim, and we just started getting to know each other. And I was also getting back into gym training. So at that point, I trained a little while, but not a lot. And I was just starting to get back into it at that first year of university. And that kind of combined into, I just did not go down the path at all. For me, it was totally 100% focus on gym, focus on studies, focus on good eating. And it didn't pay off dividends in the first year, but man, it paid dividends in the second through the fourth year. And it just obliterated it pretty much. So you can get very different experience of engineering.
Yeah,
so I think it's interesting depending on which path you take into it.
Yeah. I'll describe my first year as well, which was very similar to yours. I think in a sense, mine was, I guess, tempered by the fact that I was still very socially anxious. So what was probably actually a negative was that 2 very good high school friends of mine, 2 very good and 1 sort of acquaintance friend, all joined the first year engineering. So that was Stephen, Manshil, and Harry actually did engineering for the first 6 months or year. And that was actually probably a little bit of a negative for my personal growth because I had a home base. I didn't need to go out and make other friends. So I'm just trying to think, a lot of people say like your friends in uni, those are the ones who stick with you for life. For me, no, it's the high school friends. And so Yeah, definitely would see the party people.
Yep.
And it just never interested me.
You know, it's interesting. I never put much thought into it, but on my first year at that engineer, I remember the absolutely first when we were all talking and chatting to people, I knew one person from high school, which was Kirsten McIlroy, who I found and I just sat next to. And after that first day, I basically knew nobody and just started talking to random people.
Yeah,
that's how I made friends with Jimmy and other people.
Nice.
But I still considered myself at that point very shy.
Yeah.
So, but
well, this is okay. This is
there's levels. There's levels here. There's a level here, folks. Okay, so we kind of gave it a picture of the first year of engineering. I want to get to
and contact hours. I don't know what yours were. I think mine were hovering around the 30 contact hours a week
per week.
So it'd be like roughly 6 hours per day, Monday to Friday, and then you'd obviously have assignments and stuff that you have to do on the weekends.
I think in the first year of engineering, I was still can't really recall it, but I was working, so I was able to work maybe 10 to 15 hours a week, and I'd probably say about 30 hours. Yeah. Now as it scaled through, those hours became much more and much more, but that was also level to how well you want to be doing. Way more. You're talking about contact hours that is forced on by the university?
Well, not forced. I mean, that is suggested, I guess. So it's like a lecture.
Yeah, no, it was. Yeah, it went 40, 45 hours, 50 hours.
Oh my God,
yeah.
What the hell?
Yeah.
No, mine dwindled, man.
Really?
I was down to 20 per week.
Okay.
And even then, that was when I learned, I don't actually learn that well in lectures, so I'm going to stop going to lectures.
I had 2 4-hour lectures.
Yeah, I never had ones that big.
Yeah, 2 4-hour lectures. Screw them. Don't even go to them.
Go to
and
UQ,
we'll probably get until it's
out.
out.
Go to UQ.
Worst case. What's some of the worst stuff about engineering?
Worst stuff?
While obviously being in university. There's while you're in university, while you're learning.
Okay. I found the learning system there quite tedious, I would say.
Yep.
There was a lot. This was when Blackboard wasn't that great and they wouldn't record all the lectures.
Yep.
So it was very hit and miss because sometimes you'd have to go to them because you just didn't know if it was getting recorded.
Yep.
I think now they record basically everything, which is good because then you'd be able to just, go online, catch up that one you missed. So that sort of didn't work well for me because, as I mentioned, I just don't learn when there's someone speaking in front of me. I can't write quickly. Like there's notes coming up, but I'm not really learning. I'm bored. It's 8 a.m. in the morning. I don't want to be here. I'd rather be doing other stuff. So that I found really tedious. Everything else apart from that, it's sort of like you get out what you put in. So I would say I didn't have that great a time at uni from sort of years 1 through 3. But then year 4 was when I started going to the gym on that first semester. And then that's when I started approaching girls in the sort of second semester after that. And that's where I was like, oh my God, uni is the best place ever. There's just girls everywhere.
But this is engineering. This is engineering discussion.
So, I don't have that much to say. I didn't particularly enjoy working with the international students because some of them, their English was just so bad that it made a lot more work for me when I was doing group projects. And we had a lot of group projects, I would say.
A lot of group projects.
Group projects towards the end were basically everything that I did. Yeah.
If I had to summarize and say, just engineering at university for me, what were the key things you had to be really good at? You had to know your specifics. Especially for exams, you had to know your maths. You had to know... give you an example. I had an exam in 3rd year, I believe, which was all around earthquake and like structural integrity with earthquake and tornadoes, right? And there's a standard for that. It was an open book. You literally bring anything you want, and in 2 hours, you have to go and show how you design a building so that it can withstand earthquakes and tornadoes or anything else or high winds. Now, to do that, you need to be on point, on your game, because a lot of people had failed it because they couldn't even finish it in that allotted time. So you got to just know your stuff, I think. And what I mean specifically by that is you got to know the principles. You got to know the principles. So I got the chance to do a lot of tutoring when I was in year 3 and 4th year as well. And I took one particular class 2 times, like for 2 years. And when I tutored that, I learned more and more that training people or teaching people around the principles of something was 100 times better than telling them directly what it was. So I can recall so amazingly well. There was a question in all the exams. I don't know if it's still in the exam in the QT, but the structure is pretty much like this, and then it connects to a wall. So it's connected here and connected here. And there's all these loads, and loads change in the moment or whatever else. But it essentially teaches all these principles about, at that point, structural engineering. Points, nodes, moments, vertical loads, distributed loads, all this sort of stuff. And I saw a lot of times when I got taught that, it was a little bit like, oh, here's what you got to do for this thing. Here's what you got to do for that thing. And, well, that's useful for that exact shape. As soon as it changes or something else changes, you kind of like, oh, I don't know what's going on. Yep. So I found that learning the principles paid dividends. Like, especially through the last years, I was able to just do, especially soil. Like, I just didn't do it for too much, but I just like smashed soil because I just knew the principles. And once you know seepage theory and everything else, everything is like piss. You essentially could do any question at that point, or moments or loads. So it was that. And I think it was learning to network in the right way. So I ended up at the very end as well, knowing my lecturers, knowing my tutors, knowing the people who I was working with. And I think that's kind of like how I've translated it now into my working life. But having that relationship with people, not in a deep, friendly way, but in a, oh, I know you, you know me, we can have this conversation, man, proves like just really, really well.
Yeah. I want to ask, so you said that it paid dividends studying really hard in that first year, sort of first, second, third year. How so? Why was that?
Well, because so
I know you've also mentioned that not too long ago that GPA doesn't matter once you get out, essentially from
I'm going to say right now, does not matter. It does not matter what your GPA is.
Okay, so how do you balance those two sort of opposing, contrasting views in a way?
So not contrasting because and specifically in engineering, as I was saying, engineering is very practical, and we'll probably get into that a little bit. So that's what I'm saying. GPA, as long as it's enough to get you in the door, that's it. Then you can throw it away, basically. But when I was in first year of engineering, I really didn't know that. So at first year of engineering, I thought, okay, I've got to do my utmost. So at that point, first year, I had no idea of all these things. So for me, it was just, work really hard, see how good I can go with this. Cool, we'll go from there.
Yep.
It was in fourth year that I was able to look back and go, it was excellent that I was able to build such a foundation of all the principles of engineering, especially the civil and structural ones, because now I've cemented them over 3 years and I can reflect back on them. So I think I did the right thing, but not knowing back in the first year.
Yep. Okay. So, yeah, there you go. So for me, it was very similar, I guess. Like I had a first year. I think I came out of it with a GPA of 6, which was,
I think mine was even lower.
Yeah. And I think what sort of saved me, I guess, was one, I had a really cool lecturer and who took a liking to me, even though I didn't really communicate with him that much. I think he liked me.
Yep.
And when I was applying for scholarships, I got some interviews and I didn't do so great. There was definitely people who were more friendly and chatty than me, who had more volunteer experience and things like that, who had better GPAs. But I was doing mining, which was very specialized, and a lot of the scholarships right then was right at the sort of like edge of the mining boom, starting to go down. So there's money being thrown around. So I got very, very fortunate in that, a couple of things worked out for me and I ended up getting a scholarship. And then I sort of had a very smooth sailing ride through uni with Rio Tinto, which I'm, forever appreciative of. And I sort of gave them, 3 years of work and didn't even think of looking for work elsewhere because it was,
it was
paying back what was due. So that for me was also a big like moment in a sense, which was, yes, I did work hard right at the start and it paid off. And, I was never going to party anyway. So, I might as well be working hard in a sense.
The only one I'm going to touch on before we probably use that as our stepping stone out of here, so engineering, I've talked about it already. It is pragmatic. It is about being practical. So, if you're doing engineering right now, you're thinking about going into it, try and pull as much of that about the practicality of doing it in real life as possible. And so a little example is one, I had this awesome lecturer as well that I really liked, Tommy Chan, Dr. Tommy Chan, awesome guy. He's from Singapore and just awesome about bridges. Now I went in to do my master's by research with Dr. Tommy Chan, and it was about vibrational analysis of cable-stayed bridges. I think it was something like that. Vibrational harmonious, something like that. It was actually really exciting. But one thing that I noticed was if you do a master's or something of a higher level and it's in engineering, it is an incredibly like niche field, and you're going to have to become either a scholar or a researcher for another place. It is very, very minute chances that you're able to use that, leverage that to go elsewhere. You're going to be pinned into a very specific space. So here's an example. I was, 3/4 through the Masters of Bridge Engineering with a civil engineering degree. And I applied for a particular job at AECOM, which they wanted a graduate engineer to go into the space of bridges, like into the bridge team as a graduate engineer. And I lost that job, and I asked for feedback around it. And the person who had gotten that job was someone who had 10 years bridge experience in the field, plus the degree. And I was like, God, mate, okay, this is just silly. So that's the level of, if you get that niche, there's going to be people out there who, depending on the market, that sort of stuff's going to happen. So, but let's use that as a stepping stone off. So engineering is a very practical position, I would say.
Do you want to know probably the main thing I learned from uni, which was don't study the things that aren't important. So you'll get there's probably a Pareto principle before I was really applying it, but it was essentially, there's huge amounts of information in each of these courses. Each course, you're doing 4 courses a year. 4 courses a semester. And there's just a lot. There's a bulk, 13 lectures for the 13 weeks, plus all the supplementary, plus the reading manual if they tell you to get that, or which is incidentally most of the lecturers wrote that book that you then have to buy, of course. So I learned very quickly that what matters is the grades for me. So it was particularly just studying for the tests and studying for things that were assessed and counted. That's what I would study for. So even if there was, this certain lecture on this topic, but I saw, we're not doing any tutorials on that, or we're not doing any tests on that until the end of the year, I don't need to learn this. And so I would just study the exams, I would study the tutorials, I would make sure I was at every single accessible piece that there was, but all the external stuff, and that's what I was saying, like lectures, okay, they're not assessed, I don't need to be here, I can go elsewhere. So that's sort of my learning from that. And that could have made me a bad engineer in a way, because maybe I'm not learning those principles and basics, but that's usually what are on the tests. So I would get the most of that. And then the other thing is mining is, I don't want to be too harsh, but I'm going to say I don't think we got the brightest of the bunch in mining. I think a lot of the really bright kids went into the electrical, the civil, the mechanical, and we got the man chills.
I was going to disagree profusely with that. With the learning and the principles, but I think you saved it when you started talking about it. And then I thought, you know what? The only reason I'm having this thought is because I didn't stick around in engineering. So I think you're right. A lot of the engineering professions, because they are so pragmatic and practical, look, as long as you're just getting passable grades and good grades and focus on the things that you get to do, legitimately, once you start working, you'll really know how to be an engineer, right? So this is where I was getting at. For me, I'd still say just learn the basics, as in the principles, the foundation. If you come out of engineering as a civil structural engineer and you don't understand what a vertical structure and the shear walls and what a moment, a load, points, how to use strand 7, fighter element, if you don't know how to do that, then you're not a structural engineer. You're just useless at that point, because you might as well get someone off the street to go and do some calculations who knows maths. So you need to know that. You need to know what standards you use, either literally printed out or ready to go, right? So that's one piece. But now let's talk engineering in real life. Once you move into a profession, so I'm going to talk not so much the civil work that I did when I was in local government, because that was, it is engineering, but in a way, but it's more, there's policy, there's a bit of engineering, there's a bit of whatever, transport, whatever. It's just a little bit different. But I'll talk specifically to the private place where I worked at. Now, structural engineering there was all about, I'll give you an example. I'd come in to this place and I'd have my standards handy. So I'd have them in digital copy, but I'd also have a printout copy, and it came in handy because you did a lot of calculations. And I'd have I think it's AS3600 and a couple of those, right? So it's just steel standards, concrete standards, all these sort of stuff. And you'd have them all sort of ready to go. And then depending on what you're working on, so for me, say one in particular is a 11-story building in Townsville, the Ergon building. So I did the majority of the engineering on that. Now, to do that sort of work, we would get the architectural design come through from the design AutoCAD, which fortunately for us, we had some not architects, but AutoCAD designers on hand. And we would get architects that we would work with for this building. They'd essentially pass you through the designs and say, this is what the architect wants and what the person wants to get built. And you go, okay, cool. Now let's go and figure out exactly what that means. Now, there's the perfect example of in engineering, if you're at university, you're going to get given this pretty little diagram with a load here, with a load there. Now, if you start getting a bit complex, you'll see real life, here's a pipe here and here's an angle here, right? All this sort of stuff. If you know the principles, you're going to get better. But at this point, you're given a whole building, and they go, all right, start designing it. Where do you begin? And this is where the pragmatic view it is, because the standard, so this is going to be specifically for civil structural, and you tell me if they're similar to mining, and there's maybe similar to the others, is the guides are there as sort of protecting security things. So you'll generally design something, and you can design it off first principles, or you can design it based on the guides. But generally, the guides will then give us like a 20% buffer, essentially, to say, okay, you designed it, it can be done this way with an 18 millimeter rod. Use a 21 millimeter rod though, just in case. There's everything a little bit of just in case, right? But so the example of why you got to be pragmatic, if you're sitting there, if you've gone through engineering thinking, here's one design and here's my load, and you ask, well, what's my load? What's my vertical distributed load? What's all this stuff? No, what you got to go and figure out is, at that point, you go, okay, if I'm on the 11th floor, what's the expected, and this is in the standards as well, so it gives you an idea, but what's the average loading for a penthouse? How many people are walking about? What's the timing of that? Do you have equipment on the top floor? What's the span of those concrete columns to your slab to give you all this sort of stuff? Now, at that point, you go, okay, is it pre-tensed steel? Is it not pre-tensed steel? Are you using it? What's the momentum going through? And then you use all your tools, right? You got your, what was it called? I'll call it Strand 7. There's a couple of other ones that you can use, those softwares. But all of this makes... So you'll do it once and you think, okay, even if you get given the information, here's it, cool, whatever. So you'll get a couple of days into it, and then the architect will come back and say, actually, we want to extend the balconies a little bit more and we want to reduce the concrete here. We want to do this. Can we do that? And that's where, as an engineer, that's going to be a little bit pragmatic and go, okay, well, I know that I did those calculations already and had a 30% margin of safety. Okay, yes, we can reduce that and I'll go and confirm, but it can still be within the standards. And then you got to remember, so this is a pretty crazy one. So imagining a column coming in and you got your slab here. Now you'll design it in the office and you'll go, of course, you need a steel rebar that's 9 meters long and you'll need another one here that's 7 meters long. And then they're building it, or they're out there with a construction site and they'll go, sure, theoretically that's why it works, but physically you can't fit 3 Rio bars of that size into this space in the way that they've got the framework and the cage bars and stuff like that. That doesn't work. You can't do that. So that's where you start learning as you're going on the roll. You go, okay. Even though theoretically the cheapest is to go with 3 Rio bars of 27 millimeter width, actually you need 2 42 millimeters because yes, I'll give you the same strength and it's actually practically possible, not just theoretically possible. So I think all of engineering for me came to, you just got to be practical. And the more senior you got, and I think this applies forever, you begin to make decisions off the top of your head, of practical reasoning. So one of the partners there, which was a really cool guy, he would be able to tell you, so you'd say, I've got a house or a shed out here. It's in Western Australia in this particular zone. And he'd be able to do napkin calculations to go, cool, you need this sort of steel rear bars, you need this I-beam, you need this U-beam, blah, 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 these rafters. That's what you need. And he'd even get to the point of, you roughly have about this much load of water onto your gutters, and the gutter has to load this much, blah, 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 bang. So, and that's all pragmatic. That's not you just knowing, like being a polymath, being able to calculate all these crazy things. No, it's just you knowing from experience and just being practical about it.
Yeah, I think it's just getting into that practicality, like you mentioned, where just because this circle is this big and this pipe is this big and it should fit in there.
Yep.
Yeah, you very quickly realize, especially when they take it to your face. And how often would you go and physically see these things that you think like, oh, okay.
Pretty often.
Yeah, and that's probably the most important and the best thing to learn is just because something looks very pretty on your diagrams and on your computer, when you actually go out and see it and you realize like, oh, that thing is bent as hell. There's no way that's getting in there.
There's all this sort of stuff, right? Here's another one, and you start thinking, just because you're a civil structural engineer, you have to then be practical and know a lot of other things. So one of like another example, we designed this building. It was like a 3-story building with a couple of other people, and our design was, you get these seal, because there was to be a like flat concrete packs on the outside, and we thought, you can just have one big pack because it's not too hot, so it won't expand, and blah 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 blah, until someone was like, you can't get a 20-meter slab of concrete out to freaking middle of Western Australia. Like, we cannot even transport that. It's impossible. You can't do that. You have to actually figure out a smaller. I was like, okay. Yeah. So it's all this stuff where you don't even think about it if you're looking at it in theory.
Yeah. Yeah. Well, I guess my experience, I would say, is a little bit different from yours, because mine was more around logistics. So what going through mining engineering, you do a lot of stuff related to safety. So you do courses just on safety.
Yep.
You do courses on, I guess, like the JORC, I'm gonna really struggle, the resource like calculation something.
Okay.
And it's essentially saying like, okay, the standards for how calculating how much resources are actually in the ground if you're doing calculations on that. But a lot of it was just simply doing the designs for what the mine would end up looking like, whether it's a underground mine with the tunnels and whatnot, an open cut mine, an open strip mine, where you use different sorts of machines. So it was more getting used to, okay, this machine can do this is its limitations, this is how much it can use, and then it's essentially just, big blocks, and it's going, okay, if I take this block out first, I can then get at this one, but that means I'll be delayed in getting this coal that's underneath. So maybe I should do it the opposite way, and figuring it out, how machines can work in different areas. I like that I brought my little dozer here so we can play around with that. I think, the most important thing I learned was probably within my first year, 2 years, was number one, just because someone says something, like, it doesn't mean that's actually a problem. They might just want to bitch. Okay. And so a lot of times, I would think, oh crap, this is bad. This is really bad. This is like, what are we going to do here? They're saying it's like 2 meters above where it needs to be. And that's going to cause like all these drainage issues, all this stuff. Just went away. The guy just wanted a bitch. Going out and actually seeing stuff, like you mentioned, where it's, okay, that might look really nice on my design, but going out and seeing, oh, okay, I can't actually do that. And then, just in mining, safety is a big one. So if someone was bitching about safety, that's when it's like, oh, okay, this is going to be an actual problem, because that's just going to delay everything. So, that, I think those were my major learnings. And then actually just, spending a lot of time going out into the actual pit and seeing stuff. Getting stuck behind your computer was it would get old. It would get old really quick.
Now I know we're going on for a while here, but I wanna make sure that we talk about probably our worst or funniest moments in engineering.
Yeah, I've got some.
I would like to hear it. I'd like to hear one. Hit me up.
Okay, so my worst one was probably there was a bunch of misfires. So that's basically when the explosives don't go off and they're sort of trapped in the ground, which is very dangerous, because if you're coming in with a big machine like a dozer and it catches it right, and some of these explosives were about the size of my phone, a cylinder about the size of my phone, and that sets off like the big volume, the liquid explosives that you put in the holes to actually blow up the rock. So if you hit one of these, that can just send shards of rock piercing flying through glass and whatever. So you have to be very careful with them. So I just had this one dig where it was just an absolute nightmare. Absolute nightmare. You had to do, okay, we're going to go down in these levels, we're going to do all these things. So we had this, multiple meetings adding up into this cumulative meeting where the guy's like, the guy who has the final decision. Okay, we're going to dig at 8 meter intervals, and then we're going to backfill. They had all the process in, and The only thing that mattered to me was 8 meters.
Yeah.
Okay, 8 meters. I got to do my designs at this level, and this level. Sweet, I can do that.
Yep.
And then it was a Friday afternoon, going out just to check it just before their weekends.
Yeah.
And we go down there and I'm like, okay, these are the designs. I've already printed them off for the weekend. This is what you're going to be doing.
Yep.
And he looks at it and goes, why are we doing 8 meters? I just went, because that's what you said, man. And like this, obviously I didn't say that to him. I was well, in the meeting we discussed, you said 8 meters. He just went, yeah, I don't know why I would have said 8 meters. Like 4 meters, we should be doing 4 meters.
Dang.
And so I just had to do all this redesign work on a Friday afternoon. And that is my biggest bitch about my job and what I had to do, just the rework, man. Redoing designs, redoing calculations because something changed.
Yep.
Was just horrendous.
So I mentioned the story about that Ergon building. I easily would have gone past 20 redesigns. But by the time, and I was doing this the steel rebar designs because this particular company didn't have they did have the AutoCAD, but they didn't have the particular software to do Rio designing. I was doing them by hand, 11 floors. And by the time all these updates came through, because every time so if you adjust level 10, it can change everything. Now you can leave it if it's just reducing stuff, but then you're also now making it uneconomical. So you can make it more economical. So yeah, the rework is just an absolute bitch, man. Just Jesus. Mine was probably, I don't know if I've shared this one with you. So this is working at Brisbane City Council. Now I began I was pretty fresh here, right? I'm still in university. Doing sort of my the sort of work that you have to do before you graduate, your required hours, and I went into development assessment. So I don't know if you know what a development assessment is in the council.
No.
If you put in that you want to build a fence or you want to build an extension to your house or anything else, you generally have to apply to the council to say, hey, can I do this, council? And the council will say, no. Whatever it may be, right? So I was in this particular group. There was around 10 to 15 engineers, and we were tasked with the entire Brisbane City Council doing a development assessment. So as you can imagine, it goes from small things to very large things. And the example here is there was a really big design going down in the city. So this was one of the new buildings that was going up back then. So in 2012, a building was going up. And I got given, can you approve the parking areas as well as the traffic area to make sure it's all meeting standards? And they have all these standards that you have to meet. So the parking, I was able to just go through, check, confirm that it had the right width. Because sometimes what happens is planners and designers, what they'll do is they'll send it to council hoping that they don't check this. I swear to God, the people that I worked with, that could be true. That could be true. So, if a car park's going to be 3.4 meters length and 1.8 meters width, they might say, they'll go 1.6 meters width and 3.2 meters length and go, but it's a small car space. But there's, again, there's a certain ratio that you can have, that sort of stuff. So anyway, so the car park, cool. It was all fine. And then it came to the traffic stuff. And this happened to me twice around the traffic things where I had no clue. I had no clue about what was even being asked here of the traffic side, because it was just mental. They were just saying things like, can we close it between 9 p.m. to 7 a.m.? And there wasn't a regulation to this. There was nothing. There was no standard to say, you should check. This was just pure, what do you think about it? And on 2 occasions, one in the city and one in the hospital, the new hospital that went up in South Bank?
Yeah.
That I approved some traffic work, some traffic work at nighttime that I never was able to check and confirm where these people who were requesting it. And I remember once someone coming back and there was a complaint from someone in South Bank area saying, this seems to be excessive amount of traffic things, and can you please check it? And it came through directly to me, and we sent back a reply saying, no, we can't. And that was it. And I was like, I have no idea what's going on here. It was so abstract. Even to this day, they still stuff it up so much, but yeah, I stopped that up big time.
Every time I hit traffic in South Bank, I'm blaming you.
Yeah, it's my fault. It's my fault. You can blame it on me.
Old decisions catching up. Nice.
And the biggest learning from engineering? What's the biggest learning? So obviously we're both used to be engineers. We're no longer engineers, right? We are mere mortals.
Yeah.
We are podcasters. I'm a consultant. I do many other things. But what would you say of your timing engineering, which was a combined 7 years learning and working? What was the biggest learning? that you could still say you carry to this day, that people could say, okay, I'll do engineering if I get that?
Yeah. Okay. Look, I mean, the biggest learning I think is sort of outside of it, which was, engineering was taking up a lot of my time, and that time I wasn't using for self-development, and I wasn't focusing on the things that really needed focusing on. So, the biggest learning for me in that sense was, why am I doing things which aren't really, really improving me or helping me? From engineering though, I think the tracking of numbers is probably, I could probably trace that back a little bit to, I was keeping very detailed spreadsheets of, how much coal we were moving, how much dirt we were moving, what was the efficiency of this and that and all these things. And that was probably when I got into work in 2014, 2015. I think that was roughly when I was starting to create a lot more detailed budget tracking spreadsheets and nutrition and fitness and health and things like that. So that was probably another big one, which was the understanding of just how important data is and how useful data is for getting a clarity of the situation, what's going on.
Yeah, okay. Nice. For me, and this is just, you always hear it, problem solving. That's the biggest thing I took away. But specifically in the civil structural, it's the breaking down of big things into small things. So I gave you the example, 11-story buildings, you could have bridges, you could have dams, you could have whatever it may be. When you look at it, it's a big, humongous mess. But I learned learned through all those years the ability to break things down into the sort of like primordial units that you should tackle. And when you can do that and sequentially go through it or in a different array, you can then come to the end and go, okay, cool, you've solved it. And what began as this huge hairy ball is now just a small little puppies that you can sort out on the way.
Yeah,
and get it all sorted out. So that was biggest learning.
Yeah, okay. I've got a couple of funny stories, which I think I should tell them.
Okay.
It's probably one of those ones where it's like, if Rio Tinto saw this, I mean, I don't work for it anymore, so it's probably okay. But
Rio Tinto is going to be sponsoring us from episode 150 onwards.
I don't think that's going to Number one was the animals at the mines. There was all sorts of animal problems. And it's just so strange because you're in the middle of nowhere and it's, just a barren landscape, essentially. My mum and my family, I brought them to the mine on like a visitor tour once. And my mum just said, like, this looks like Mars. This looks like the moon. It's just so barren, dirt, nothing going on but big machines moving around. And all the like funny random shit that happened was related to animals somehow doing things in the mine where they shouldn't have been.
Yeah.
So number one, this cost tens of thousands of dollars, was a turkey ran into one of the substations and got electrified. So, just the classic sort of don't touch these things, grab onto them, like Homer Simpson in that episode with Frank Grimes.
Yeah.
Oh, electrical, I shouldn't touch it. That sort of stuff.
Yeah.
Turkey did that, cost tens of thousands of dollars.
Nice, good turkey.
A guy ran over a cow once.
Oh, yep. I know, I've heard the story, yeah.
That was pretty messy. That was like just an understanding of how big these machines are and what they can do is just ridiculous.
Yep.
Absolutely ridiculous. And then just understanding working with people and just meeting like some people who just shouldn't be in a workplace. Like there's definitely some jobs which should be assigned to people where they don't get to interact with others because they just make a mess of it. So I had two people like that, and I won't talk that much about them, but just the stories that come out, it's almost like you need to treasure them as much as they make your life hell. Like I was talking about with my friend Marcella and her workplace, which has got Tina, and she was not too happy with Tina. It's like you got to enjoy those people as well.
You do.
It does make it interesting.
Yep.
Interesting. I wanted to ask you about where was it? The 6 classic simple machines. Have you ever heard of this?
No.
Okay. So,
maybe.
So I just was looking at engineering.
Like levers.
Yeah. So do you know what they are? Have a guess at what the 6 classic simple machines are.
Levers.
You already got one. Yeah.
I'm gonna say something like cylindrical. Is it clogs or something like that?
They got wheel and axle.
Okay, axle. Yeah, I was thinking. So lever, axle, plank.
Plank, sort of. It's like a inclined plane, so a ramp.
Okay, a ramp.
And then there's a movable version of that, which is the wedge.
Yep.
A screw, and then a pulley.
So yes, pulley. That's what I was thinking. Yeah,
just very simple things. I never actually learned this. And this
man, I learned all the pulleys are an absolute bitch. Holy shit! Have you ever looked at the mathematics of pulleys?
No.
Gosh, man. Everything else so easy, but pulleys just mind-bend you and just bend your mind.
Now, you also mentioned problem solving, which was one thing I've got here. So I was saying, I was going to ask you, are you getting that enough now? Because it's very different. You're, I guess, problem solving with people. Does that solve your itch that you...
No, problem solve to this day. Yeah, I do a lot of problems. So everything now that I do, I take those principles for sure. So I'll give you an idea. So for all intents and purposes, I do some work in websites. Let's just keep it as simple as that. But these websites are very complex. So if you're out there and you think you're a website developer in that, cool. I get it. This is much more complex. But imagine a website that, imagine look at your Adobe Audio, right? That if you were given that by Adobe and said, build it.
Yeah.
You could either stare at it and be like, I have no idea what the hell's going on. So for me, it's the ability to go down, okay, well, it's got units that break down into this main section, this section, the settings section, this section, the menu section. Okay, now what's important around these, what's needed, how they connect, all that sort of stuff. So I still use it to this day. And I always used it beyond engineering. So of all the places I ever worked at is like, say, Accenture in general, with a lot of the stuff, especially when I was doing tenders, even when I was selling. So when I was doing tenders and submitting tenders, for me, it would be, you get an idea of, hey, this is what I need you to go and do or deliver for a particular product. And it's understanding, okay, well, let's pull this out. What does that mean? How does that break down? What does it need? Does it meet their values? Does it meet their intent? Okay, how can we deliver this? So I think I learned, do it, for sure. And every day I reckon I do that. So even with our marathon planning. So for me, it's imperative to break it down to small units that I can then chunk up and then do.
Yeah. See, I enjoy that sort of thing as well. Just bits and pieces here and there, but it's not like I need problems every day.
Scientists theorize. Engineers do.
To finish this off, I wanted to go into the etymology of engineering, which we didn't do.
Yeah.
So it's derived from the Latin ingenium, meaning cleverness.
Ooh.
So that's it. The
clever engineers. Clever.
Confirmed. Latin confirmed. Good. Etymology confirmed. Wikipedia confirmed. Thank you.
Immortals has been episode 109 engineering. 109. Karen, is there some last words you want to share with the listeners?
I think they should go check out some of the videos. The quality is getting a little bit better.
I'm really liking it. The video camera is good.
Experimenting with some different things. Getting some people interacting with us more.
What was her name? Michelle? What's her name? Michelle? Just recently we've been talking to on Instagram. And forgive us for continue though.
Yeah, I could be. Anywho, we're very active on Instagram and on the YouTube comments. So if you comment on either one of those, we'll be getting back at you. We appreciate you and taking the time to reach out to us and whatnot. So those are the two places. Also, once again, I think the book reviews. I think for me, that's like, if you want the most densely packed value that we have to offer, I would say go to the book review. Because
I agree.
I feel that's the one I practice the most. I put the most attention in, and like hours of reading
for the minutes, bang for your buck. You're going to get some good stuff out of the book reviews.
So, yeah.
That's right. I know. Yes, it was Michelle, and I want to give a little shout out because in case she's listening to this, or her son is, because she has a 16-year-old son who is autistic and high functioning. However, she believes that perhaps listening to us, the aspects that you might find, it might be helpful for him. So that was really cool to see that little message from Michelle. So if you're listening to this, Michelle, or her son, thank you very much.
Yeah, we appreciate it. We really do
appreciate it. And all the messages that a lot of people get through. We had this discussion already in the past now about the amount of messages coming through and making sure that we don't overread them so we don't forget them and essentially get lost in the pile, because there was one message that almost got lost in the pile of messages. So very cool stuff.
Very good.
Mere Mortals, episode 109. One out.
Karen out.